Hello, everyone. My name is Fernando Mayo, and I'm going to talk about testing. So a bit about me. I'm the CTO and co-founder of a startup called Undefined Labs. At Undefined Labs, we build tools for developers to make them more efficient, and we are focusing right now on solving the issue of testing complex microservices. Previously, I co-founded another company called Turum that was a container management platform that was acquired by Docker in 2015, where I spent a couple of years. So the agenda for today is going to be first, why testing, and why testing is cool and you should do it. Why testing microservices is so hard. A bit about testing in production and different techniques that we can use to test directly in the production environment, and how can we use the distributed context propagation system of tracing in order to help with that. So debugging an issue in production using observability tools is great, right? We're all here because of that. But it should be really our last resort. We shouldn't be using that every day. It should only happen a few times in the month. Why? Because solving an issue in production is extremely expensive. If you are solving an issue in production, you have to think about all these costs. So first is the detection cost. Can you detect that your application is not behaving as expected? You might be able to detect a spike in latency and a spike in error rate, but do you know if it's actually returning the right thing? Then it's troubleshooting it. Have you added the right instrumentation in order to be able to troubleshoot that issue? Do you have the right sampling? Do you have the right retention? How much does it cost to store and analyze all that data for troubleshooting? Then is the fixing cost. Can I roll back and fix that temporarily? Do I have to roll forward? Do I have to come up with a hotfix? Do I have the people that can do that? Do I have to clean up any data stores that have been poisoned? Verification cost. Can I even verify that the fix actually fixed the issue? Or do I have to ask a user to basically verify it for me? Then is the user impact cost. Of course, if you are debugging an issue in production, it's because some users have been impacted. So how many? For how long? How much money have we lost? How much impact has our brand reputation had? And it's also engineering burnout. So someone will get paged because of this. So we want to reduce those pages at a minimum. So as issues get closer to the end user, they are more expensive to solve. So how can we avoid that? Well, there's a thing called testing that is actually, it will actually help with that. So testing is about reducing the risk of your application not performing as expected at the lowest possible cost. So it's about reducing the risk because testing will never be able to tell you that your application is 100% correct. That's impossible. But it's going to be able to reduce that risk in a very cost-efficient way. And it's about reducing the risk of your application not performing as expected. Not performing as expected means robustness. So that will be probably hitting your error rate SLOs. Performance will probably be some latency SLOs. And correctness is about your application returning the right thing, which is not so obvious. So in the monolith era, testing was great. It was easy. It was good times. We had a 3-tier architecture, for example. I'm developing the backend service, so I could really replicate this stack anywhere. In my laptop, in CI, staging, production, I can run a few unit tests, integration tests, end-to-end tests. I can run all this even in my laptop. And then in production, detecting and troubleshooting issues was really easy. It's just monitoring some metrics, using some logs to troubleshoot what the problem is. So it was relatively easy. But in the era of microservices, this becomes a bit more complex. Now I'm the service owner of this little box that is part of a greater application, a greater thing. I still have to test that service in isolation. I still have to be able to make sure that it's correct. I can run unit tests, I can run integration tests. But now, because I don't have access to my downstreams, I cannot replicate them. I can replicate the Uber architecture that we saw before. I'm forced to use mocks, to use contract tests, to use traffic replays, and all these techniques in order to isolate my testing from my downstreams. And then we throw that service to production, and we have now tracing to troubleshoot issues, which is great. But we have created a wide gap between the environment where my service is being tested and the environment where my service is actually running and actually serving requests. So that gap creates a big risk. So if we can no longer replicate production because it's the number of services that we have in production, configuration, SSL certificates, traffic patterns, scale data, release cadence. So different teams will release services at different times, and that's very, very hard to replicate in any environment. Let's directly test in production. But before we get too excited about that, let me say that production testing is not a replacement for pre-production testing. We should still test in pre-production before releasing to production. It's much cheaper, and we can do that in an automated way. So think about testing in production as another technique that you can use next to pre-production testing, and that it requires investment to do it right. So testing in production is not free. It's not shipping my code to production and see what happens. We actually have to code for it. We actually have to do some investment to do it right. So when we think about testing in production, we think about many techniques that we can apply to make sure that our application works as expected when deployed in production. So it goes from the moment we deploy the new service, and that service is running in production but not serving any real user traffic, to the point where that new service is actually handling 100% of user traffic. Between those 2 points, we have a number of techniques that you might be familiar with in order to make sure that our application is behaving as expected at any point in that process. So all these techniques have some risks in common. So the first one is user impact. If you are testing directly in production, you have to make sure that users are not affected, or the minimum amount of users are affected. The second one is state poisoning. If you are releasing an untested version of your application in production and you start throwing tests against that, you have the risk of poisoning your data stores. So then you have to be able to clean them up if something goes wrong, which is not easy. Traffic saturation. If we do load tests and stress tests against production, we can actually saturate the end-user traffic, and we can actually cause an outage. Telemetry data skew. So if we test in production and we have these versions of our applications that are being tested, we also have the risk of polluting our telemetry data. So now we won't be able to differentiate between what telemetry data is related to end-user traffic handling and what is related to test traffic. And because of that, we can have misfire alerts. So if we have alerts on this telemetry data, we might fire pages based on tests that go wrong. So in order to mitigate all these risks, we have to make sure that our application is aware of tests being made in production. So imagine for a moment that we have a way to label every request that goes into our production application with a test label. So it can flow through our application, and every service and every router or the routing layer will be aware of those requests being test requests. Will that solve the problem? If we go to the risks, we have, for example, user impact. How can we mitigate the user impact risk by using this label? Well, if we use this label, we can actually be able to test services before they are released to users. If our routing layer is able to differentiate between test requests and end-user requests, we can actually direct those requests to services that are not receiving any end-user traffic. State poisoning. If our services are aware of test traffic, they can actually handle that appropriately. So, for example, stateful services that need to write data can do so with a flag or a different database or a different table in order to separate that test data from the actual end-user data. Traffic saturation. If we do load tests and stress tests against production, and we can label those requests as test requests, we can make sure that our routing layer can apply quality of service rules to that traffic. So we can, for example, have less priority for those requests, have rate limiting, or even kill it if there's something going on in production and we want to stop all the load testing in production. The telemetry data skew. So we can mark all the telemetry data that we produce, so metric, logs, and traces that come from test requests as test telemetry. So we can then later on use that label to differentiate, to have different dashboards for what the end-user traffic telemetry looks like and the testing traffic. And because of this, we can make sure that our alerts are not fired because of testing telemetry. How can we implement this label, this magic label? Well, we have context propagation. Context propagation allows us to attach arbitrary metadata to the current request that will be propagated automatically to all downstream dependencies. Observability and tracing is based on this primitive. So context propagation comes for free with tracing. So if you are using OpenTracing, OpenCensus, or OpenTelemetry, you will have context propagation built in. He has a very developer-friendly API, so the developer can set and get any key values on this context at any point in the request. It's compatible with threads and coroutines, so it's scope-aware. So it will actually attach that context to the thread or coroutine that is handling that request. That comes with the library. And it's compatible with multiple synchronous and asynchronous protocols, so the context propagation will actually work through synchronous protocols like GCP and gRPC, but it can also be extended to asynchronous protocols like message queues. And we just have to be aware that everything that we add to the context will actually increase the request size, so it will make processing those requests a bit longer. So the current state of context propagation, for example, in OpenTracing, which is an API, it just defines the context propagation, the arbitrary context propagation as baggage, so you can attach baggage to any request. It's key value pairs, and because it's just an API, the tracer is the one that will actually define how that gets serialized and deserialized. So depending on the vendor and depending on the tracer that you use, that context will be propagated using some headers or others, or some format or other. In OpenTelemetry, this is still work in progress, but as of this morning, it was called distributed context. It's still key value, but now we have some metadata that we can attach to that baggage, like TTL. The serialization in this case is done by OpenTelemetry SDK, so it will be common across all vendors. And at the moment, it's using the W3C standard correlation context, which I'm sure some of you are involved in, which defines what is the format for serializing this context, this baggage. So at the top, we have the format of the trace context. So that's how tracing information will get serialized. This is just trace IDs, parent span ID, sampling information. So just trace a specific information. And that is actually in candidate recommendation state. And at the bottom, we have the correlation context draft, which is how our arbitrary metadata will get serialized. And as I said, this is still work in progress, but this is the current state. So we use this context propagation technique for propagating tracing information, so then we can troubleshoot issues in production. But we can also use it for other things, like, for example, our test traffic label. We can use this system to mark individual requests as test requests, so we can then act accordingly. We can also use it for fault injection. So on every request, we can actually specify instructions for faults in line that will only affect that request and not an entire node or an entire service. We can also attach things like user account information and feature flags that will go into a bit more detail now. So for example, if we want to do integration testing, we are developing our service SVC, and I have a bunch of downstream dependencies that I cannot replicate locally because they are too big. I don't have the data, I don't have the configuration, I don't know who is developing them. So what if we point our service that we are developing locally against production, and every test that we make, we actually attach a label to that request that says tenancy equals test. So I'm marking that every request I make to my downstreams is a test request. So how do we do this? As I said, the API is very easy. So as a developer, I just have to start a trace in my test. This is an example using Go. I start a trace, and then I attach that baggage to the trace, saying this trace is a test request. So this context will be propagated across all the requests that I do to my downstream dependencies. Now, on the downstream dependency side, like in the server side, we have to be able to handle these requests. So imagine that I have a stateful service, and I'm making a request that will actually write some data. So in order to do so, this is the simplest way to support that use case, which will be deploying two separate instances of my service, one for handling end-user traffic and another one for handling test traffic, and then letting the routing layer be the one that actually decides where to send the request. It will read the correlation context header and will say, okay, this is a test request, so I will redirect it to the test version of my service. And then every service can have its own data store, so basically you have a new completely separate tenant in production for testing and another one for end-user traffic. We can get a bit more sophisticated, and we can make our service actually multi-tenant, so we can have the same instance of our service be able to read both end-user traffic and test traffic. And then if the data store doesn't support multi-tenancy, we can still write to different databases in order to separate that state. If we have a data store that supports multi-tenancy, we can just have the same service, only one service, and one data store that actually supports multi-tenancy, and we can use this tenancy label to decide where to store the data, where to read the data. And then if we want to test against the actual end-user data that is already there in our production environment, and we don't want to start from scratch and start populating data, we can actually make the service so it can read from end-user data, but when it writes to a different tenant. It writes to the test tenant. We also have to manage telemetry data. So as I said before, if we are not careful with this, we have telemetry data that is for both tests and production traffic and real end-user traffic. So we have to be able to mark those metrics and those traces and logs with that tenant label. So this is an example of Go, which is an API that is still work in progress. But the idea is to, for every metric that we create, add the tenancy key, add the tenancy label. So when we emit metrics associated to requests, they are actually segregated to the right tenant. They are either end-user metrics or test metrics. This will allow us later on to build dashboards that are for end-user data or test data. And then in order to manage other side effects that you might have, we can just read that tenancy label from the distributed context. So for example, with this, we can actually implement the multi-tenant storage by asking to our tracing library, what is the value for the tenancy in this request? So if it's a test tenancy, I can actually use the test database. But also, for example, using sandbox accounts. So if our application is using a third-party service like Stripe, and we are charging credit cards, we can actually use this tenancy in order to use a sandbox account instead of a real account. So we can avoid these side effects. Another example of using context propagation is end-to-end testing with services that are not yet released. So imagine that I have my service, V1, serving end-user traffic in production. I deploy, but I don't release my V2 of my service. So this is running in production, but it's not actually receiving any end-user traffic. I can then send requests against production that has a label saying, I want this request to target the V2 version of my service. So if my routing layer is aware of tenancy, the routing layer can actually redirect that request to my service when it goes to my service. So it will use all the production environment of my application, but before it goes to my service, the service that I'm responsible for, it will actually go through the new version. And I can test that that service is behaving as expected without affecting any user traffic. Like end-user traffic doesn't even know that I'm performing tests against production. If this test fails, I can then roll back and I can clean them up. Another example is fault injection. So unlike traditional chaos engineering where the whole service will be affected or a whole node will be affected, using context propagation, because it's tied to a specific request, we can actually inject instructions for a specific test request to inject a failure somewhere in the service. So in this case, I'm saying I want this test request that goes against production to introduce, for example, an HTTP delay on every client request that I make in my service. So this test request will go through all the normal flows of production, but when it goes to my service will actually understand that instruction and it will execute it, so it will actually introduce that delay. So with this, we can synthetically test that my service will, and the entire application will behave as expected when I introduce this failure. So this is a very fine-grained fault injection that we can do using context propagation. Feature flags, for example. So I have some code in my service that is behind a feature flag, and I want to be able to test it before releasing it to users, because I want to mitigate the user impact. So in this case, I can attach an instruction to my correlation context saying, I want the feature 1 of my service to be enabled for this specific request. So nobody will see that feature, but I can run an end-to-end test against production that will actually go through that code and test it proactively before we release it to end users. Another example is using test accounts. So the correlation context is not only set at the beginning or outside of production. Any service in my application can actually add that label. So, for example, if we have an authentication service in our application that looks up the database of users and can see if the user is a test account or not, it can actually inject that information into the request that will be propagated across my application. So I don't need my services to be looking up, be asking my authentication service whether that user is a test user or not. I can add that information in band, so every service in my application will actually know that that is a test account and will avoid side effects like charging credit cards or sending telemetry to a different tenant. So what are the consequences of all this? So the first thing is that if we design our applications to be able to be tested in production, we avoid the need to have to replicate our application stack anywhere. So we don't have to run it locally, we don't have to run it on CI, or even staging. Staging is hard. So by testing in production and by having test accounts and sandbox accounts in production, we can avoid having to replicate that stack, which probably is impossible to replicate. By segregating telemetry, we can actually monitor and troubleshoot tests like we monitor and troubleshoot any end user traffic. So this is much more rich information that we can use in order to troubleshoot why a test failed, instead of just a dump of logs. And we can add other types of traffic to our application. So by using this technique of using context propagation, we can actually add, for example, sandbox accounts. So if our application is actually a downstream dependency of a customer, we can actually mark all the requests that come from the customer using a sandbox account as sandbox traffic. So we can have different quality of service rules. We can have different segregated metrics, different alerts from the actual production traffic. Or even development traffic. Maybe all our services are developed against production. So the user doesn't have to replicate anything locally. It doesn't have to connect to staging or anything. They can actually connect to production where all the services are there anyway. So we can mark all the requests that go to production with a development label. So we can make sure that there are no alerts fired if something goes wrong with that development traffic. We can actually have different retention rules for logs. We can have different levels, and so on. So the key takeaways is that we should catch issues before, as early as possible in the cycle through proactive testing, because it's much cheaper than actually solving that issue directly in production. Testing in production can actually be the most efficient way to test, and sometimes the only way to test complex architectures, because we just can't replicate it anywhere. We should design our applications to be able to be tested in production, so it needs investment. It's not free. It doesn't come for free. It's not just throw something in production and do some tests. We actually have to be conscious that we are testing in production, and we have to be able to code for that. And let's make use of context propagation. We have instrumented our applications already with tracing. So let's use that context propagation system that we have in our applications for testing, so we can make the most of that investment, which is a big investment. And with that, thank you. And if you want to talk about testing, I'll be available later.
Awesome. Questions? See one in the front here.
Hi. So the magic sauce that you're using here, is this, are you talking about Envoy or Istio to enable this labeling and the routing?
So, yeah, so proxy support right now, no proxies or service meshes actually understand this correlation context, but it could actually be implemented in Istio or any API gateway, to be honest. So at the moment, it's an HTTP header, which means that at the moment you have to code some regex on your service mesh, Istio, or even API gateway. You can do this with Nginx. and make sure that it reads this correlation context header. It matches the string that you want to. At the moment, is string matching. And then if, for example, there's a test request, I want to redirect it to the test version of my service. Hopefully, when the standard, the correlation context standard actually gets through and approved and all this, service meshes will actually start supporting correlation context in a better way. So it can actually understand all the baggage that goes through them, and you can actually have more sophisticated rules based on that baggage. So you can say, okay, I want every request that has a test label actually do this or have this failure, or we can do more things. But at the moment, because there's no standard, is based on HTTP headers, so we have to make sure that the service mesh or API gateway that you use actually can read that and can process it.
Other questions? We got time for one or two more. One back here.
Yeah, hi.
Hi.
Thank you for the demo. So at what point of time you are talking about like the testing to be done in production? Are we saying like immediately releasing it to the production? Are you talking purely from the GCP ISTO, which is coming up with like a new kind of model or whatever?
So, sorry, can you say that
So
again?
at what point of time are we talking about like this production testing needs to be done? At what point of time? Is it immediately releasing the product? Is it after some time? At what point of time?
How often do you test in production?
Yeah. When should we test?
When? So, yeah. So we can test in production across all these steps. So what I would do is I will try to test after deployment but before releasing. So that's the moment where we will have less user impact because no one is actually exposed to the new version of the service. So by using this label, we can actually redirect traffic to that version of the service that is not yet exposed. That's the moment where there's less impact. So I will try to do that as much as possible. If you can detect it in that step, it's much cheaper from an impact perspective. But you can do it later on. Like you can actually you can run this periodically if you want. So you can run it you can run it after deployment, but you can also have CI run end-to-end tests with this label every 5 minutes, every hour, to make sure that your application in production still works as expected, and still have this segregation of telemetry and avoiding side effects.
So what is the benefit of like running these tests after some time once the product is released?
Just to make sure that your service is still compatible with all the other services that have been deployed. So production will change over time. So this is more of a synthetic monitoring check. It's not a test, but you can do synthetic monitoring using requests with this label and do more advanced checking of if your application is actually behaving as expected or not than a ping to an endpoint.
So is it not going to result in overcost?
It will produce an overhead, but I think it's better to have that overhead in your production system and actually catching issues before users do. I think it's worth it, and especially if you have coded your application, you have programmed your application to not have side effects of those tests. So yes, you will have a bit of overhead, but I think the cost justifies it because you will be able to catch issues before your users actually start complaining.
But the same thing we do before moving it to production anyhow, right?
Sorry?
The same thing we do before moving it to production anyhow, right?
Yes, it can be a subset of that. It doesn't have to run your entire test suite against production, but you can run a subset of tests against production to make sure that it still works.
Okay, thank you.
Thanks. No problem. Okay. Maybe one last question. Do we have Emre here, the next speaker? You want to start getting set up and we'll do this one final question?
Do we see this as a security risk? Because anyone could add a baggage and send a request to you. So
that's sorry. That's a good question. Yes, you have to make sure that unauthorized users can set the package arbitrarily. So if you're inside the application, that should be okay. But from outside, you have to have some way of authenticating that request outside of the package. So yes, absolutely. You have to make sure that not a random user cannot just send a request with a package. So probably your edge entry point, like your edge router, will strip that out, and you have some other way to make requests against production that is not the standard, like not the user-facing way. But yeah, that's a concern. Awesome, thank you.
Congratulations. Give it up for Fernando.